All right. I want to cover today a couple of topics that are a little bit confusing if you've never seen them before. I will admit that when I first saw these, it kind of took me for a loop. But upon a little bit of study, they really weren't as difficult as they may seem. The first of which is called LINQ, L-I-N-Q. That stands for Language Integrated I think the I and the N come from the word integrated query. And what does that mean, language integrated query? It means that we're not doing like we did in the bad old days and writing a SQL statement in a string and hoping that string was a valid SQL statement. All right, that's what we did before. In other words, the SQL wasn't really integrated into C#. And what I mean by that is it wasn't integrated to the degree that if you had an error in your SQL statement, it would not show up as a compile error. It would show up as a runtime error. And a runtime error is, as the name implies, an error that appears when the program is being run. And it usually occurs under certain circumstances. Most bugs are like that. I mean, it's very rare that you have code that always blows up, right? Someone's really not doing their job if that's the case. But typically the bugs that you get in are ones that under certain circumstances, like, you are doing a query on state and you select more than one state, and you also do a query by age. All right. So a query by age and state where you select multiple state, just some odd combination of factors usually determines where there's a bug. Where language integrated query gets around that because the compiler is going to check the statements, because we're not dealing with simple strings where the compiler has no idea if that's a valid SQL statement or not. But it deals with LINQ objects and methods and things such as that, list objects and methods and that sort of thing. So that's the first topic we're going to talk, or that's one of the topics we're going to talk about. LINQ, by the way, is a way of querying more than just databases, but it's used for databases as well. You can do LINQ queries on a list of items, on a list of objects. So you have a lot of flexibility. I think you could do LINQ queries on an XML file, I think. All right. So it's really an overall arching way of doing queries on a number of different things. And the thing is it's built into the language. So if you have something wrong, it's more than likely going to show up as a compile error as opposed to a runtime error. All right, the second thing we're going to cover is Lambda expressions. These really threw me for a loop when I first saw those. This was very puzzling, and it took me a while to really get to the gist of them. Lambda expressions are sort of shorthand for a function. Let's say I wanted to write a function that converted centigrade to Fahrenheit. So I could write a function like this, function double C to F double arg. return arg times 9 divided by 5 plus 32. I think that's a formula for converting centigrade to Fahrenheit. All right. I could write a lambda expression as sort of an anonymous function. What does anonymous means? It means it doesn't have a name. And I could make it a lot clearer to exactly what that function does. So, for example, my lambda function would look something like this, or my lambda expression would look something like this. X and I always say goes to when we have that equal sign greater than sign combination. Is meant to look like an arrow. Is input to would be another way to say that. Is input to the expression this would be a lambda expression to do the exact same thing. Well, look how much more concise this is. Once you get your head around writing lambda expressions, they're actually fairly straightforward. All right. What would be a lambda expression that would test if someone's age was above a certain amount? See, we'll look for an age greater than 65. Look like that. All right. So it's a little snippet of code, and it's going to set age to, or it's going to take as input as an age. It's going to give that to the function. A is greater than or equal to 65. So that function, that lambda expression will return a true if the age is greater than 65, or less if it was not greater than or equal to 65. Now here's the thing. Let's say we have an employee class in our application. And that employee class has an attribute of age. I could say something like that. Or this. It's going to take as a input an employee object, and it's going to take that employee object and look for the age related to that employee object and make sure it's greater than 65. So that's a lambda function or lambda expression. I keep wanting to use the word function. It's sort of a replacement for anonymous functions. Now, how do these connect? Well, we'll see that in a minute. Let's look a little bit more at the resource I posted. LINQ and Lambda expressions. This is filtering a collection using a C# Lambda expressions. All right. we have a function called find all. And we can use the lambda expression as an argument to the find all method. So let's look at this code. We have a list of animals. Owl with a W, should be with an O, but that's okay. Owl, bear, beaver, snake. I'm creating a list of animals starting with the letter B. Equals, take this list of animals as input, find all what? Find all that match this particular condition. And that particular condition says where that list item, that animal, starts with B. A in this case means each individual string in that list. Because that's what all the find all means. It says find every list item where this is true. And we're looking for the list item starting with B. And we could write code to do that. We would loop through list of animals for each animal and list of animals. You know, what would the code look like? It would look something like this. And I'm not gonna get the syntax right for each a match this list of animals. All right. This would also create a list called list of animals starting with B. But it does it in a very programmatic way. It does it step by step. This is the equivalent of this. Well, that was a nonsensical statement. It does it in a very programmatic way. Of course, it's a programmatic way. It does it in a verbose way. Let's put it that way. A lot of statements just to do that one thing. Whereas that could be accomplished by calling the find all method on the list and specifying what the conditions that we need to match. And in this case, that A starts with B. And we end up with a list of animals, start with the letter B, and we can then loop through all of those and output the name of the animal. Now, that's all well and good with strings. We're going to be more dealing with we're going to be more dealing with lists of objects. Because when we do a query, what are we getting back? We're getting back a list of objects. So if I retrieve all the movies in the movie database, I'm getting a list of a bunch of movie objects. In this case, they just defined a new object as animal that has two properties, bear, or animal name, and age. And what this will do is this will give me a list of all the names from that list of animals. So list of animals select. The select statement gives us what? Well, it takes each list item and uses it to give us the name related to that. When we execute the code, we get this. And we can sort. And so on and so forth. All right. Now, that's in a nutshell what LINQ expressions are, or Lambda expressions. Now, how are we going to be using them in LINQ? And what is LINQ? LINQ, as I mentioned before, is a language integrated query. And it will allow us to query list of things. All right, those things can be strings, numbers, objects, whatever. Now, there's two ways to write our queries in LINQ. One of them is sort of a quasi-SQL mode, where we write statements that look a lot like SQL statements. I have a feeling they put this in the language to ease the transition for people that have been working with SQL for a long time, because it's very SQL-like. I prefer the second method, which is the method, where we use LINQ methods or list methods to do our queries of those lists. Let's see if I can find that anywhere among these resources. LINQ tutorial. Yeah, here we go. What is LINQ? Different ways to write a LINQ query. They call them the query syntax, the method syntax, and you can mix and match. The query syntax is where we write our LINQ queries to kind of look like SQL queries. The method syntax is where we use list methods and Lambda expressions. And the mix syntax is a mix of both, because we can mix and match. So here's an example of a query syntax to pull all of the objects, all of the items in the list that are greater than 5. So from object in integer list, where the object is greater than 5, select object. This is very, very similar, especially when we talk about databases, to a SQL data select statement. I would assume you all have had CISS243 and done some SQL selects. The SQL select would look like this if we were writing it. Would look something like this. And it would be put in a string. The SQL statement would be put in a string, which would be no way to verify. Is there a variable called OBJ in that table? This is assuming integer list would be a table with one column OBJ, and so on. Here we do the same thing, but we'll get compilers. If there's not something called integer list, we get an error. If OBJ would happen not to be defined, we would get an error. My suggestion is to be aware of this method, but we're going to use the method more than we're going to use the query method. And the method syntax for the same thing would look like this. We're coming up with a list of items from integer list where for each item we're going to look and we're going to include it if this is true. So if the value of OBJ is true. And then it's going to take all those items that we've selected and make a list out of them. So as list processing is sort of like a pipeline. We start out with a list of things. We do stuff in the middle, and then we output a list of things. Now, we don't always output a list of things. In some cases, we output an individual item. All right. But in many cases, like on the index page, we're going to output a list of items. Now, when you substitute, instead of having a hard-coded integer list, with a list of objects that are in our data context, that is within our database, this effectively will do a SQL query and will pull out where OBJ is greater than 5, all the elements in there. And there's a mixed way of doing it. I don't like that way either. So we're going to, in most of our examples, I believe most of the examples I'm going to show you, we're going to stick with the method syntax. So what does this have to do with our ASP.NET Razor pages? Well, I've written a modified version of the movie application that we've been using. I wrote it with a different search query than the one that was included in the tutorial. I'm going to run it and I'm going to show you how it works, and then we'll look at the code for this. All right. I put in the option, I put in an option to search by price. If I don't have anything in there, it's going to give me all the movies. If I put an item in here, I can put a price in, and then I could either select those that are less than or equal to or greater than or equal to. So if I picked less than or equal to, I would expect to get nothing because they all have at least a price of $16. If I put $24 and say less than or equal, I should get all of them. If I put greater than or equal 24, I get none of them. If I pick greater than or equal to 12, I get all of them. Now, this is an interesting question. How many test cases would you need to thoroughly test to make sure this works? Let's go through the process. We're going to need at least 2, right? Because I could either pick this or that. That's a branching point in the logic. So therefore, I have to consider both those situations. I would want to test right on the number. So for example, if I say greater than or equal to 20, it ought to pick up the one that costs $20. I would want to try just a little bit above 20 to make sure it doesn't pick it up. Then I want to do a similar thing with less than or equal to. Less than or equal to, what's the lowest one? 16. Put 15.99 in. And finally, 18. Greater than or equal to. So we want to test the two possibilities that are in our drop down, but we want to do at least 4 or 5 test cases for each of them. I would say probably about 4. So don't just run it through once and say, oh, yeah, got it, it works. All right. Thoroughly test it. And that includes, like I said, testing the borders, testing the edge cases. Of what happens if I have a value so low that it picks none of them, a value so high that it picks none of them, a value so low that it picks everyone, a value so high that it picks everyone, a value right between the border where I put in a value that is slightly above or slightly below one of the prices. All right, let's look at the code that does this. This will be similar to what you have seen, but you did a different sort of search on this. All right, here is our CSS_HTML file. Here is our .cs. All right, I do not like the way, and I mentioned this before, I do not like the way that it puts these properties in the middle of the methods. I would prefer to put all the properties at the very top of the object. Now remember, what are these properties? These properties are things that we can use on the Razor page itself, in the CSS_HTML file. So our model is going to fill these in. And the CSS_HTML file is going to use them to form the page. So one thing that we're getting is we have a list of movies named movie. All right. We have a search string, a search type, and an error message. Search string and search type is coming from the page when we submit the page. Our error message is if something potentially goes wrong, we're going to fill that in and have the CSS_HTML page retrieve it. On get async, we initialize the error message as nothing. Oh, I forgot a couple of test cases. What if we put in an invalid number? What if we leave it empty? Those are all valid test cases too. All right, I lied a little bit. Here we're using a mixed method. We're saying from context movie. What is context movie? That's a list of the movies from the database. I am selecting each of the items in that list. So we're going to start out and we're going to form a list and we're going to narrow that list down with our filter. So right at this point, this variable movies has in it a list of all the movie objects. That's what this instruction says. Var, which means of a variable type, from M in context movie. So for every item in the movie list, give me that item. We could say, give me just the title and the price of the item if we wanted. So we could say M dot title, M dot price. Not price. Or we could just get the title. Notice I can't put in some nonsense here. Why not? This is language integrated. It knows that there's nothing in the movie object called name of movie. Instead, it is title. And IntelliSense even gives that to us. So at this point, after this executes, we have a list of movies from context movie from the database that contains a list of all movies in the database in a list called movies with a capital L. Now, we're looking and we're making sure that the search string is not null or empty. So what are we testing for here? We're testing for when the page initially loads. Oh, I forgot I changed that. See? Good thing about it being compiled, right? Catches my mistakes. There we go. Because we want we want the whole movie object, because we're going to do something with each of the pieces of the movie object. So search string, we're looking to see if it's null or empty. Well, wait a minute. What is search string? Well, search string is the value that we type in here. And sure enough, if we submit it with nothing in the search string, we get every movie. But how do we know? How does the model, how does the CS file know that this text box relates to search string? It knows this way. When we declare search string, we bind the property. That means we connect the properties of the model with the properties of the CS HTML page, and we're saying supports get equals true. What that means is it's automatically going to get from the query string the thing that is named search string. And what is the name of the thing called search string? It is the value of that text box. So by virtue of this having the same name and support get equal true, that will automatically fill that variable search string from the query string. And notice that it shows up on the query string when we submit. Search string, we type in a value. Search string equals 12. So There's nothing entered in there. We don't do any filtering. And we simply take that list of movies, which has not been filtered, it hasn't gone through this code. Therefore, it remains as a list of every movie. And we turn that into a list to put in movie with a capital M. So we're filling in movie with a capital M. Remember, we're going to use that later on the index page to display all the movies. Now, one thing I want to demonstrate today is running this code through debugger. Well, I'll demonstrate that in a minute here. Let's let this go. What happens if there's nothing in, what happens if there is something in the search string? Well, if it's LE, we want from that movie list, look at each item in that movie list. And that's what this means, each item individually. And we want it if this condition is true, that is if the price of the movie is less than or equal to the search string when we parse it as a decimal. Remember, the search string that comes in on the query string, all those items are strings. Search type, by the way, is similarly bound to the page, and it also supports get. So that gets populated automatically as well. So we apply this where, and our argument to the where is the expression, which for each item will evaluate to true or false, and it will come out and it will create, it will overwrite what was in movies before with only a list of things that meet that criteria. That is less than or equal to the search string. And if we don't pick less than or equal to, we must have picked greater than or equal to. All right. In which case we do the reverse. We check to see if it's greater than or equal to the value of the search string. In either case, movies then now has a list of filtered movies because we recreated that list with the results of this where function. This where function returns a list of items in this list that match this criteria. We make a list out of that, it gets put in movie. Now, how is that used? It's used down here. We pull out for the first element, we saw this before when we looked at it, the title, the release date, the genre, and the price, and the director. That's pulling the headers, the first row of the table. We then are looping through for each item in model.movie. That's this guy here. That got filled in here from our sort of working list that we use to come up with the final list of movies. And we loop through it and we display for each item title, release date, and so on. And that's how we get our list of things. Now, a couple things I want to show you before we end up today. Number one, what if we type in something bogus? So I type in a non-numeric value here. I get invalid entry, right? Let's see how that comes about. Well, where are we getting a problem if we type in something that's not numeric. We'd get it either here or here, depending on whether we pick less than or equal to or greater than or equal to. It's going to throw an exception. Well, we're catching that exception, and we probably should do more extensive exception testing, but we're assuming that if there's an exception thrown in any of these statements, it's because we entered in the wrong number or the wrong value for the field. And that is certainly probably the most common thing that could go wrong here, provided the database isn't really messed up or something like that. We have not converted, we've not created this movie list, so therefore there's no looping done and we don't get a list of movies. Now let's say, for example, I did something wrong. Let's say I made this less than instead of less than or equal to. All right. Now we can see that that's wrong, right? Because we know it needs to be less than or equal to. Well, let's say we ran this and we got unexpected results. So I put in 20 and I only get the 1. I should get 2 of these, right? I should get The Empire Strikes Back and Star Wars, because this one's 20, this one's 16. If I put in 20 and say less than or equal to, it should give me these 2, but only gives me that 1. Now, the answer is pretty obvious here, but let's pretend it wasn't obvious, all right? Because you will run into problems where it's not really clear where the problem is. What do? There's a couple approaches that people take. One of them is to just stare at the code. All right, I wish there was a camera on me because you see the expression on my face. You sit here, propping up your head with your fist and elbow on the table, and you stare at the code until something jumps out at you. Well, that's not a really effective tool, especially if things are complicated, and especially if there's a long set of instructions here. A more experienced programmer will use the debugger built into Visual Studio. Now, what is a debugger? Some of you, I would hope have seen this before. I hope it's taught in the intro to C#, but I can put a breakpoint somewhere in the code. Let's put it here. And when this is hit, we're going to X-ray into this code, and we're going to be able to trace through the code one step at a time and check the variables and see if we understand what's going wrong. So I'll run this. Didn't want to do that. I should have. Stop. Put it here. So I don't get it when the page initially loads. So we go in here. We type in 20. We click submit. It now jumps into this code. All right. Maybe this statement we coded wrong, right? Maybe we said, something wrong here. What I can do is I can step through, step into, step over, step out. Step into, we'll go and execute that instruction, and we'll keep the flow going where we see the next instruction and the next instruction. Step over, we'll say, do not process the rest of this, go to the next instruction. That's useful if you don't want to go into a function to see the details of it. And step out means to just exit that function or work that's being done. I'm going to do a step into. And where are we? We're here. Let's do step into again. Okay, so we're hitting this line. We know that this if statement worked the way we expected it to. So there's not a problem with this if statement. Movies we can go and look at, and we can actually look into, see our movie objects. First one's an ID of 1, it's sci-fi, the title somewhere down here is Star Wars. We can actually see the value of the items in that list. And now that we're looking at the code one at a time, it points to this and say, and we can look at and evaluate what's wrong with this. Hopefully, now that this is highlighted and we know this is a line of code which does the final filtering, we can see that it should be less than or equal to. I'm going to ask you, if you come to me with a problem with code, something like this, I'm going to ask you if you ran it through debug. All right, because it's important that you at least try it. I don't expect you to be an expert in this first off, right off the bat. All right, but I expect you to try it out and gain some experience. And if you can contact me for problems, I will ask you, I will run through debugger with you, and we can see and we can trace the exact code and see exactly what's going on. And hopefully that will allow you to pick up the skills to identify. Step out, and we see that it should be less than or equal to, and everything is happy again. All right, these are important concepts. I realize they're a little tricky, and they're a little different than maybe some of the code that you've seen before. It'll take a little while to get used to, but I will say that in addition to teaching this course and to teaching the Java course, both for here at Learning Community and for University of Akron, Lambda expressions are getting to be very, very popular. So it will behoove you, if you are seeking a career in this field, to get an understanding of Lambda expressions. All right. All right, that's all I had for today. If there are no questions, we'll either see you in lab or we'll see you next week. Take care.